The Internet Mail System has been around since the early 1980s, and from being a tool for scientists and researchers, it has become an integral part of our everyday lives. Despite the advent of instant messaging and social media for business and personal communications, the use of email continues to grow. As of 2020, it is estimated that over 300 billion emails are sent and received every single day, amounting to a mind-boggling 110 trillion emails every year. In this video, I am going to give an introduction to the Internet Mail System, from what happens when you click send on an email to it arriving in the recipient's inbox. We'll introduce the standards and processes that form the Internet Mail System. The history of the Internet Mail System goes back to the 1960s in the United States Department of Defense Advanced Research Project Agency Network, or ARPANET, which was the forerunner of the modern Internet. In 1971, Ray Tomlinson invented email. This included the use of the @ symbol to distinguish between who the message was for and where their computer was. For the first time, people connected to ARPANET could exchange mail between users of different computers. In 1981, John Postel created the Simple Mail Transfer Protocol that described the process of transferring email between hosts. In 1982, RFC 821, the formal specification of SMTP, was published. It was the standard definition of Internet email transfer for nearly 20 years. During the 1980s and 1990s, the growth in use of Internet mail identified weaknesses in the original SMTP specification. To resolve these, extensions to SMTP were published to add features such as authentication and encryption. In 2001, RFC 2821 replaced RFC 821 as the official definition of SMTP. It is also known as Extended SMTP. It incorporated many of the widely used extensions and best practices into the SMTP specification. In 2008, another revision of the SMTP standard RFC 5321 was published that incorporates further features and aspects of best practice. RFC 5321 is the current edition of the SMTP specification. In the previous section, we introduced something called RFCs. The Internet works through the systems connected to it, conforming to standards that define how they must interoperate. For the Internet, these standards are defined in documents called RFCs, or requests for comments. Each RFC defines some functionality or process that supports activity on the Internet, for example, email. An RFC has a title and a numeric identifier, and are often known by their identifier rather than their title. RFCs are maintained by the Internet Engineering Task Force, whose mission statement is itself defined in RFC 3935. Once accepted, RFCs are never modified, but as we saw earlier, they can be superseded by newer versions. Although the standard for Internet email is specified in RFC 5321, there are several supporting standards that supplement it and define the extensions to it. If nothing else, the list of accompanying standards for SMTP suggests that using the word simple when naming a protocol should be avoided. While we're thinking about standards and RFCs, it's worth pointing out that RFC 5321 and its companions only define how an email is sent. There are separate standards that define how the content of an email is formatted. Like SMTP, there is a general standard for the format of Internet email, which has always been numerically the RFC after SMTP. RFC 821 had RFC 822, RFC 2821 had RFC 2822, and RFC 5321 has RFC 5322. Also, like SMTP, there are a number of accompanying standards that define some of the details that the general standard doesn't include. Now that we've covered some of the background to the Internet Mail System, we'll take a look at how it works in practice. Each part of the process of the transmission of email has a particular role. The main components are the mail user agent, message submission agent, message transfer agent, and mail delivery agent. The MUA is used to create, send, and receive email, for example, Microsoft Outlook. The MSA performs authentication and content validation. The MTA transfers the message to the host responsible for the recipient's domain. The MDA puts the message into the mail store used by the recipient. In RFC 821, the original SMTP standard, the MSA didn't exist. One of the changes in the later versions of SMTP was to introduce separate roles to support best practices for security. The process for sending an email works as follows. A user uses an MUA to create and send an email. When they hit send, the MUA sends a message to an MSA using SMTP. The MSA performs any necessary submission checks and then submits the message to an MTA using SMTP. The sending MTA determines which MTA is responsible for receiving the message based on each recipient's domain. The MTA then forwards the message to the receiving MTA, again using SMTP. The receiving MTA performs inbound validation checks, such as verifying recipient addresses and spam or virus detection. Valid email will then be transferred to the MDA possibly using SMTP, though this will be dependent on the implementation. The MDA adds the message to the recipient's mailbox store from where the recipient's MUA can retrieve the message. Since SMTP only defines how mail is submitted and transferred, the protocols for retrieving email from a mailbox store are defined by separate standards. The two most widely used are Post Office Protocol 3 or POP3 and Internet Message Access Protocol 4 or IMAP4. POP3 is the oldest and was defined in RFC 1081 in 1988. IMAP4 was defined in RFC 1730 in 1994. Going into the details of how they work is beyond the scope of this video. The main difference is that MUAs using POP3 store messages on the client, whereas MUAs using IMAP4 access emails stored in the mailbox store. The main advantage of IMAP4 is that it requires less storage in the client host and can potentially be used to access a user's mail from any internet-connected device. Now we've understood how the wider Internet Mail System works, let's take a look at how an individual MSA or MTA works. For the purposes of this introduction, we'll ignore the differences in the roles of MSAs and MTAs and only look at how they work in general. The process of transferring an email begins with an MUA opening a connection to the TCP receiver in the MTA. The MUA uses SMTP to send the message to the receiver. After the receiver has performed any initial validation checks, the message is typically stored in a queue so it can be processed by the next component of the MTA. The SMTP submission process ensures that once the receiver has acknowledged receipt of the message, an MUA no longer needs to retain a copy of the message, although many clients will do so, for example in a sent items folder. Once an MTA has received a message, its main responsibility is to ensure it is delivered to the correct receiving MTA or MDA. It does this by examining the domain part of each recipient's email address. For a message with a single recipient or multiple recipients in the same domain, the message can be placed in a queue for delivery to that domain. For messages with multiple recipients in different domains, a separate copy will normally be queued for delivery to each domain. The delivery component of the MTA is responsible for transferring the message to the MTA that receives mail for each domain. Where possible, messages for the same domain will be batched on a single connection. When an MTA is delivering a message, it effectively becomes the MUA of the next MTA. When the next MTA acknowledges receipt of the message, it can be safely deleted from the delivery queue. If a message is being delivered to a domain that is hosted by the same system as the MTA, it will deliver the message to the appropriate MDA. Once the MDA has successfully written the message into the mailbox store, the message can be deleted from the delivery queue. We'll conclude this introduction to the Internet Mail System by briefly looking at error handling. Message transmission errors may occur for a variety of reasons. For example, if authentication fails, the sender or recipient email addresses are invalid, message security checks fail, or the recipient's mailbox is full. When an MTA rejects a message, it must report whether the failure is permanent or temporary. A permanent failure occurs when doing the same thing again would result in the same error, for example, if an authentication error occurs. A temporary failure occurs when doing the same thing again may be successful, for example, if the recipient's mailbox is full. How an error is handled depends on when it happens in the MTA and whether the error is permanent or temporary. If an error occurs during the protocol exchange with the MUA, the MTA only has to report the error to the client. It is then up to the MUA to determine how to handle the error. If the error is permanent, the MUA should report the error to the message's sender so they can correct the problem. If the error is temporary, the MUA may try again, perhaps after waiting for a period of time. If the error occurs during protocol exchange with the next MTA, the sending MTA must either retry or notify the original sender of the message that an error occurred. If the error needs to be reported to the original sender, another message called a non-delivery report or NDR is sent. An NDR will contain the reason for the failure and possibly the original message as an attachment. Once the NDR has been sent, the original message is deleted. If a retry is required, messages are typically returned to the queue with a retry timer attached to them. After the retry interval has expired, the MTA will attempt to send the message again. If several retries fail, a temporary failure is treated as a permanent failure and an NDR is sent to the original sender. Thank you for watching. I hope you found this introduction to the Internet Mail System useful. In the next video, I'll be going into the SMTP protocol in more depth.